My name is Daniil. Last 6 years I've been working in a company called Quix in what we call data infrastructure team. And I'm from Ukraine, but currently living in Poland. And I flew here and suffered terrible jet lag in order to try to persuade you today that enabling kind of less technical people to build data pipelines and workflow themselves is not such a bad idea. It actually can enable the scalability, better velocity for your company, and it will eliminate data engineers as being a bottleneck in your data organization. But first, let's talk about Quix, the company I work for. So basically, this is a nice marketing slide, but in other words, Quix is a site builder that allows you to build almost any site, e-com site for an event like this, or anything anything you can possibly imagine. And it's intended for both, like kind of DIY developer and also web studios that can basically build something on top of Quix and then sell this to their clients. What's cool about Quix is that it's pretty huge. We have 273 million users from many, many countries. And arguably, 10% of all the internet websites are built on top of Quix. It used to be 7 on this slide until the day before yesterday, but one of my colleagues presented, and he said that according to the recent research that the marketing department did, it's now 10. So I probably feel free to share this. It's amazing. On the other hand, what makes Quix relevant for this conference is that we are super data-driven. Every feature goes through the A/B test to production. And currently, at the moment I'm talking, we probably may have 400 concurrent A/B tests running right now. And we also collecting the clickstream of what users are doing, and we are collecting about 40 billions of BI events every day. And those volume of data is processed by a lot of data professionals. We have a huge data organization, about 300 data professionals. But still, in the heart of everything lies the good old data pipelines. And at Quix, I checked before, when I created this slide, we have around 7,000 active data pipelines or workflows, depending on how you read them. And usually those in the companies are built by data engineers. And let's imagine a typical day of a data engineer. So a data engineer at Quix in some of the, let's say, marketing team may be working on a quarterly report on revenue. And Quix recently introduced the product called Quix Partners. So now web studios can build something on top of Quix, and for each and every site, for the revenue it was generated, we need to know whether it was coming from partners or whether it was DIY site. So the data engineer needs to adjust all the models and all the pipelines to actually provide this information for the quarterly revenue for our shareholders. But this is their main task. Meanwhile, they're opening their mailbox and seeing, oh, another team changed some column names, so action required. You need to refactor some of your pipelines. Another email saying, oh, yet another action required, we changed some implicit fields in our automation tools. Or like a manager tells you, we are collecting those BI events, and we impose schema of them, and some of them are incorrectly parsed. And why the hell, developers send events that don't adhere to schema? Can't we create a simple report? I'll provide you a SQL that will figure out those artifacts generating incorrect events and send an email to those people. Sounds pretty simple. Can you do it ASAP, please? And at the end of the day, you may come and say, oh yeah, I'm working on the important funnel report that I need on Monday. And by the way, I'm missing some dimensions. Can you please add them? Because I already know where to take them, but I need you to modify the DAGs and everything. And at the end of the day, data engineers look like this, because he didn't work on his main goals. She worked on basically doing those ad hoc tasks. But the question is, why those, specifically in 2 last cases, why can those BA analysts and sometimes managers do some of the workflow themselves? Why can't they just build them themselves, specifically when the manager says, I know the SQL that you need to use? Let's look at the spectrum of technical skills of the people in data organization. So for instance, we may assume that let's give everyone in the company access to Airflow, to GitHub, let them generate DAGs. Probably with generative AI, it's more easier than ever. But I think that wouldn't work because we tried that and people copy-pasted code without understanding what it does, and it usually fails. So while data engineers and data scientists basically know how to program, they can use Airflow. Business analysts, product managers, and other managers You don't expect them to know how to work with version control system. You don't expect them how to code in Python. You don't expect them to understand programming best practices, etc. But what we can spot is that most of these people have some or even good knowledge of SQL actually. And they're using it on their day-to-day basis actually already. We have a notebook IDE called Quix. Of course, it's in-house. We don't use Jupyter or something like that because we have everything self-made at Wix. And they're running ad hoc queries on top of Trino query engine over the data to get some results or something like that. And the enablers for this are that we have kind of structured lakehouse. So the data that is coming, it's already structured. It's represented as an iceberg tables. So it's very easy to query it. And they're already querying it. And it seems like the last bit that is missing is that they can take this notebook and just schedule it. And that's exactly what we built. Basically, here is a pretty primitive architectural diagram. I have a terrible drawing skills. We have the Quix IDE that allows you to write those notebooks and run them in an ad hoc manner. And then, when some user want to convert this notebook into actual SQL ETL, they just click a schedule button, and after review process that we impose so they don't generate some garbage, we'll generate some configs describing this ETL. Then we will commit those config files to GitHub. From there, a GitHub sync task will get them to the Airflow. And on the Airflow side, we have a DAG factory, which is just a fancy name of a Python file that generates DAGs out of the configs. There is no such real interface in an Airflow or class that you can extend called DAG factory. It's just a concept. But this DAG factory generates DAGs that actually have Trino operators in them that run those SQLs over Trino query engine and generate new tables or generate the output and then can be redirected somewhere using actions. For instance, you can set and send an email with the results of the select or formed as a CSV file or something like that. And instead of actually showing you more of these crazy bad pictures, I will do a video of the demo because I'm scared to do live demo. So here is our Quix IDE. And I will try to create that job that sends an email about the amount of invalid events by artifact. We have a playground folder. And you're supposed to write the job name, and I think it took me 9 attempts to record this video because I was stressed. Yeah, but basically you need to choose the owner because otherwise everything will become a mess. And nobody needs a meaningful description. Nobody ever does that. And what you are left with is actually interactive SQL notebook where you can do something, you can run it, you select one and immediately get a result. So instead of running select one, we will put the SQL that actually generates those email report here. And we can debug it again. We have those tables with counters of valid and invalid events. And here is a select that produces the email reports that we want to send. We can debug it interactively by running it ad hoc. For all those statements, we have a tab for the result for each of the statements. And you can see the report. I, for some reason, decided to obfuscate the artifact name because I was not sure whether I can share that in the presentation. So I did an MD5 hash. But actually, it can be something meaningful. And what we'll do now with that result set, and here is the Trino query engine that I talked about. Here is the UI for it. And you can see that when we click the run button, we actually run this SQL on top of Trino. The SQL had multiple stages because there were joins and you need to do shuffle between the workers. And yeah, now what we can do, we can add an action saying like, I want an email with those results. And because you don't want to see how I slowly type the parameters of the email, but then I do column mapping between the result set and the actual name, like column names in the report. And you can do a preview so you can see what's actually will be sent before you actually schedule this and send it. So you'll get something like this, but it will be an email body. And also you'll get a CSV attached. And to set up scheduling, like let's say we want to get this in the morning, probably at 8 o'clock. And you also can specify the cron expression instead. And also you can specify dependencies. So this job only runs when the other tables that it's based on are ready, but I'll omit this from the presentation because I only have 25 minutes. The only thing that we are left with is actually to request review. Because I built this thing, I can self-approve, so I don't need review. Hooray. And what is happening right now, the GitHub bot just committed all the config files to GitHub. And they're aligned there by the corresponding job ID folder, and we will go and examine what was generated. So here are the files. We have a job JSON describing all the metadata about the job. Some of the fields make sense only for internal usage, but we have ownership, we have actually commit message, we have scheduling here, have versioning, because we want to keep track of the versions of the job and then do comparison. And then we have queries. They lie in separate files because it makes for better readability. If we were to embed them into the JSON, it won't be possible to read those SQLs in GitHub, obviously. And also we specify actions. And we have a file for each separate statement. So we parse the whole SQL script and we separate it into the statements. We can go and examine one of those files to see the query that actually, yeah, here is you can see that by not embedding into the JSON, you can get the syntax highlight of GitHub. You can actually do a git blame and see when, which line, and by whom it was changed. You can go to the history, which currently doesn't make sense because we just generated it with the first commit. And we can go to the Airflow. That meanwhile already DAG Factory picked up the, yeah, we have 5,000 active DAGs there. And the DAG Factory generated the, out of those configs, it generated the actual DAG that will represent this job. And if we go and check it, we will see that it has a magic init operator that does some internal not interesting stuff. Then it has a sensor that waits for dependencies. Then we grouped all the queries into separate tasks for each of the statements because it makes for better readability. And when the statement fails, the corresponding task fails, and you can understand which exactly was the statement. You don't need to go over the logs, etc. But if we go to the code, disappointment. We only see the DAG Factory code, which is similar for all of the config files. And we are not generating materializing, we are generating configs instead of Python files that actually generate DAGs, because currently we can modify DAG Factory in one place. Here is another job that I deployed earlier. You have the history of runs, etc. But what I wanted to talk about actually is that we are not materializing DAG as just a Python that builds the DAG, because if you have 2,000 jobs, for instance, and then you need to change something in the approach how you translate your SQL script into the DAG, you will have to go and update 2,000 Python files in GitHub, which will be very complicated and will take a long time. In this particular case, you can just go to a single DAG Factory, commit a new change, and you can modify how it interprets those configs easily, and voila. And by the end, you can see that this job actually, when it's run, it sends an email, and you can see that I have too many unread emails in my mailbox. But let's go back to our presentation. Yeah. What's cool about the Quixflow that we built is not only the, we don't only have email action. We can export data to different CRMs, or we can even create Jira tickets out of the SQL result set. Data engineers can extend this, because action is just an operator. They can basically write whatever they want, and it will be plugged in into the system very easily. We still need to build some UI for them to enter the parameter for the action, but I think what we'll do in the future is we will follow the approach that Airflow does with DAG parameters, and we will just auto-generate UI based on the parameters that they configured. And when we basically were ready to release all this thing, we had some suspicion about the performance, and we generated synthetically about 100 configs to see how it's going, and it was not going well. And the reason for that, it generated not 100 DAGs, it only generated 50, and then some of them were disappearing and then reappearing. So something was not working correctly. And the reason it was not working correctly, it turned out that we don't read documentation. This is the first project that my team actually did on top of Airflow ever. We're not very deep dive Airflow specialists. We are more kind of backend Scala developers. it turned out that those DAG factory is a Python file that is processed by Airflow because of the mere fact that the file has a word DAG in it, literally. You need to have a word DAG in this file for Airflow to start processing it. And Airflow gives you DAG file processor timeout time for your Python to actually generate the DAG. And by default, it's 50 seconds. Because our single Python file, single DAG factory, was generated hundreds of DAGs, obviously it took a very long time, and the timeout was exceeded. And the solution around that was not simply to enlarge the timeout, because otherwise it will take 20 minutes for this thing to generate the DAG. But we sharded the DAG factory. So we created 128, or no, not 28, you can generate whatever number you want, but it makes for easy sharding of DAG factories that all basically look the same, but each of them searches for a corresponding job by prefix. So they process only some diapason of the jobs, and they all run in parallel because we have multiple schedulers. Actually, we ended up with, on production, with 15 schedulers, Airflow schedulers running in HA mode. They are not very large instances though. And you may ask, why didn't we just increase the number of processes for parsing in one scheduler? And the answer is that we didn't think about that back in that time. Because of this, we ended up with this, but we can probably try and reconfigure the thing. The reason is just it worked eventually, and we continued because we have a long backlog of whatever things we want to do before we actually get to the optimization of this thing. But still, we had some problems because sometimes DAGs were still disappearing, even though we sharded the factory. And the reason for that is this amazing property called parsing cleanup interval. And the way it works is actually, if your file, if your DAG factory, it does not generate a DAG instance for this period of time, Airflow considers that the DAG no longer exists. But because we allowed the factory to work for such long time, it actually took longer time to generate the DAG than to remove it. So Airflow accidentally sometime removed it, so we enlarged this property. And Airflow doesn't validate actually. It allows you to configure them in such an order, and it will just remove everything that you are generating. Then we figured out several caveats. One of them is that Airflow turned out to be super IO intensive. So all the synchronization goes through the database. Anytime scheduler schedules a task, it writes it to the database. Worker updates the state in the database. Everything goes through the database. And because of this, we had to scale a database to a pretty huge instance because we have a lot of DAGs in production. And the second problem was we didn't immediately realize that the problem was in the database because Airflow is kind of surprisingly resilient. When Airflow database underperforms, it still manages to run some tasks, but sometimes there are concurrency issues with and race conditions between workers and scheduler, and it kind of works, but it doesn't. And what are our future plans? So I did a demo, and I show you that the UI, and that UI is super ugly, I think. You can agree. It looks like 10 years old. So what we are doing right now, we are replacing our notebook manager with Pinterest Querybook. Unfortunately, we had to fork it because we need to tailor-made for our organization. But Querybook comes from out of the box with its scheduling mechanism. But it's super simple, and we needed something much more complex. So we will plug in our scheduling mechanism into the Querybook. So this is something that we're working on. And we also want not only to allow people to run SQL ETLs, but also Spark SQL ETLs. We want to enforce data quality tests because the thing is auto-generated. You can easily kind of generate automatically the tests also and enforce the data quality. And we want to come up with a more optimal strategy because people are specifying the time when to run the task. Why? Basically, not the task, the DAG. Probably they just need to say, I want to run daily after my dependencies are ready. And the automatic system should decide when the dependencies are ready, what's the resource availability, and to run it in the most optimal time. And we also want to parallelize the execution, because though our DAG is super simple and linear, but if you parse the SQL, you can understand the dependencies between the table as in those scripts, and you can run independent statements in parallel. And why I believe this was a successful project? Well, because now 75% of all the DAGs in our organization are auto-generated, like with this Quix IDE. And they're not written by real people, actually. No, they're written by proxy by real people. And it can be a good thing and a bad thing. The bad thing about self-service is the problems of data governance. So now we have a problem of people copying the same flows and doing the work twice or even more times. So this is another issue that we are facing, but I won't be able to cover this in this short presentation. But another cool sign that people liked it is that data engineers often use this instead of Airflow directly. Because if they can represent what they need to do as a simple SQL script, they just go to Quixflow, put it there, schedule, and they can do it 3 minutes rather than they don't need to write on the boilerplate. And I think that's it